This is Mr. Beck Does Your Homework, Physics, homework number 13, question number 8. This one says a ball of mass 15.2 grams, that's going to be trouble, make sure that's put into kilograms, is attached to a cord of length 0.638 meters and rotates in a vertical circle. Okay, so I've got this, and this is going to be a vertical circle. And it says, what is the minimum speed the ball must have at the top of the circle so the cord does not become slack? So I've got this thing rotating in a vertical circle, and I'm talking about the top of the circle. Well, what's happening to that mass at the top of the circle? I know that I have gravity pointing straight down. What other forces are on that? Turns out there's tension in this rope, also pointing straight down. Now, my centripetal force is my net force. So my centripetal force is the sum of all the forces acting on that mass. So I know that my centripetal force in this case is gravity plus tension, because all those forces are acting on the mass, and together they're going to pull towards the center of the circle. So gravity plus tension in this case is my centripetal force. Now this says, so the cord does not become slack. What would happen to the tension as this rock went slower and slower and slower? Is this tension would get less and less and less. So when this says the cord does not become slack, that is the special case where tension goes to 0 or nearly there. So that does not become slack. Well, that's pretty much where tension goes to 0. So now I know the centripetal force is going to equal the gravitational force. Well, my centripetal force is going to be mv squared over r, and my gravitational force is going to be mg. Oh, look, mass is on the left and mass is on the right. Turns out mass will cancel. So I even didn't have to worry about that it was 15.2 grams. Now, v squared over r equals g. So v squared equals rg. So v must equal the square root of r times g. This is a very important formula. Actually, it's a very important derivation, because there are going to be a number of cases at the top of the circle where gravity alone is going to pull down and make that thing move in a circular path. It could be a car on the top of a hill. It could be a roller coaster on top of the roller coaster. It could be a roller coaster underneath doing a loop upside down. If it's upside down, then the normal force on the roller coaster is pointing in the same direction as gravity, and I'm going to get this same sort of free body diagram. If the car's on top of the road, then it's going to go quicker and quicker and quicker until its tires leave the road. Well, in that situation, the normal force would also go to 0. So gravity alone would pull it around in a circle. And when gravity alone pulls it around in a circle, I get mg equals mv squared over r, and if I'm solving for that speed, it's v is square root of rg.